All right, everyone, welcome back to Tangentially podcast. I'm Zach.
I'm Calvin.
All right, and here's what we're going to talk about. So, apparently, we did have a couple topics ready to talk about today, but apparently Calvin's really fed up about something and wants to go on a tangent. So we're probably going to go start off with that, and then we're probably going to be a little bit more loosey-goosey with the actual episode. So, Calvin, why don't you talk about what you were trying to rant about to me off mic beforehand?
So is it really a tangent if we're just starting? Anyway, it's fine. Okay, so I mentioned it before that like, I'm kind of in the tech sphere a little bit, and in it, like, or I guess I should say people outside of it can sometimes get kind of jealous. I guess that's how I'll start.
Let's call it the tech bubble. I think that's the more common term, because the bubble is like this idea that if anyone tries to enter into it, it'll pop out, and all the ideas just kind of get exploded everywhere. Because tech sphere, I don't know, it sounds a little bit weird. I think we've constantly talked about it on previous episodes about tech bubble. And I think that's a more appropriate term.
To be honest, I don't really know. Like tech bubble, people call bubble for different reasons. Like it's gonna pop. Anyway.
Oh really? Okay. Well, what do you mean by it's gonna pop? And then we'll go into your rant.
Okay. So this is actually kind of related to the rant. So here's the thing. So a lot of people are like, yeah, you know, this guy is some programmer at like XYZ company. They have like meals included, lodging included, and like a 400 million salary or whatever, right? And then they're just like, I mean, the guy just sits at a keyboard and like types a couple words in and out. Like, how is he allowed to make so much money? And so if everyone has these like cushy programming jobs, like the bubble will burst, so to speak, when like something's got to give. So that's like one thing that I've heard of people calling it like the tech bubble. But
okay, but I always thought, I guess it depends. I was thinking more like the internal sphere where or the internal bubble where if you're in that mindset. I guess maybe you're all right with the whole, there's only so many people that can actually be in that area before the bubble pops out. I was thinking more like, I guess when it comes to if you're in the sphere and you have like this entire idea, like your entire world revolves around this area. So it's like you're in this bubble that just floats in the air. And the second that any bubble interacts with another type of bubble, that's when it pops out because they just can't form together. So it's like the tech bubble versus like the construction bubble, right? You can't really they're both just floating in their own areas doing their own thing, and then but if they ever come in if a construction guy and a tech guy ever come in contact with each other, it's just going to implode because they don't know how to talk to each other. It's just going to go terrible. That's maybe what I'm thinking about, is that everyone's in their own like bubble in their own space. It's like what they call the whole idea of safe space. Remember that? It's kind of like that.
Anyways, so the rant that I want to go down is like I have a few friends who are like really in that and they make so much money. And to be honest, sometimes I'm a little jealous too, but like when I tell stories about what they do and all that, like the first reaction is people just kind of like, oh, I should just quit my job, go to some programming boot camp, and now I'm going to be a millionaire too or whatever, right? And that's not necessarily true. Like, I get the idea, and a while ago there was this big push of everyone can program, everyone should learn to program or whatever, but to be an actual really good programmer is hard.
Yeah, I mean, yeah, because it's the same. I think after doing some programming back in both my university degree and maybe a little bit in my workplace, I did it like once or twice, it becomes something akin to writing a script. Or when I say not writing a program script, I mean it's like writing a book, writing a formal letter. There's the right way and wrong way to do it. Like I think, and if you give someone a problem and you say that they have to use coding to solve it, then they'll find a way to write it up that it'll work, right? It's the whole reason about like quote unquote hard coding and the
general solution.
Yeah, the general solution, right? And some people get to that general solution a lot easier and quicker than other people. And it's the same thing with writing. Like some people will get to the point really quickly in like an email or in a letter, whereas with code, and some people will take the long way around, right? It'll be like 2 pages of like nonsense and nondescript words, and then all of a sudden, then they'll get to the point. And I think that's gonna be the same thing with coding. I feel like sometimes where it takes sometimes people take the long way around, or sometimes the code is not super clean with something that could take you something that was used in 5 lines or 10 lines of code to be very simple, it could have been done in 3 lines if they just cleaned it up better.
So here's the thing that people always get confused about. So, and it's a good thing that you bring it up this way. It's not necessarily the number of lines of code that's the important part, but it's rather how the code runs. And it's something that, like, when people say, oh, everyone should learn to program, so that they, because we live in a tech world, you know, I'm in front of a laptop, you have a phone and all that. If you have some idea of how the code runs, then you have some idea of, like, oh, when something buggy happens, you go, oh, it's probably because of this or whatever, and you kind of get a better idea what's going on. So it's not the number of codes, but how it runs. So the example that I like to give, and it's a common, like, coding interview question, I guess, too. And I'm gonna, like, butcher it because it's my own rendition of it. That's why it's pretty common, because everyone has their own rendition. So have you heard of FIZZBUZZ?
No.
Okay, so we're gonna go through FIZZBUZZ. This is like an actual technical coding interview question that people give, and everyone has their own spin after, right?
Okay.
So the problem is, and you just have to describe to me how you would approach it. You can ask questions, whatever. It's up to you how you want to get through this problem, okay? So I want you to write a program that will print the word fizz if a number is divisible by 3 and buzz if it's divisible by 5. So what is your solution?
Oh, so, and the code will, first I'm going to ask about user input. Because you're saying, yes, that if the number is divisible by 3, it'll write fizz, and if the number is divisible by 5, it'll write buzz. Are they exclusive or are they independent? Like, if it's, I guess the first question is, it's just a number that's randomly inputted. Is there a range to the user input?
Okay, so I'll give you a range. So numbers between 1 and 100.
1 and 100, okay. Second question, if it's divisible by both, for example, 15, does it need to say both, or does it need to always prioritize one or the other?
It will print FIZZBUZZ.
Got it. Okay. Yeah, I just ask. I guess the pseudocode is what I would.
Yeah,
is what I would say.
pseudocode. That's all.
All right, cool. Ask for user input for a number. Then it would go into a if loop where it'll say if number divided by 3 is equal to a whole number, right? That means that's usually what that means, right? You know, if you divide it, logical, then it will print out fizz. Or if, oh wait, it would be or if. I'm trying to remember because or no, it would be if is equals to that, and then if. No, yes. So how I do? I would create a dummy variable first, and I would store the if conditions, the outcome of each if condition, which is basically if the number is divisible by 3. When I say divisible by 3, I mean, like, you know, if I divide by 3, does it equal a whole number? I would store it into that logic, and then the next if condition would do the same thing. So that way, I wouldn't have to write a third line that says if it's divisible by 3 and 5. Right? So that way, no matter what, it's always going to store both numbers or one or the other. Because if it doesn't clear the first one, it's just going to go to the next one. And then, so it would be a dummy variable or a store variable, I guess I could call it. One if condition that says if it's divisible by 3, or a second if condition. And then a second if condition is like if it's divisible by 5, you store it in that one as well. That way, it'll always print out FIZZBUZZ. So that's the way I would probably write it, give or take.
Sure, plus minus.
And then the user input would say specifically enter in a number between 1 and 100, just to be very specific.
Okay. So a couple of, like, things around it. So the problem was you have a series of numbers from 1 to 100.
Yeah.
You don't just take someone putting in a number. I give you, like, a 1 to 100, like, series of
so it doesn't, so it's not just something randomly inputted, it actually goes through each. Then at that point I would just use it. Then I would replace the user input with a for loop with if that's a problem, it's sequentially going through 1 to 100, then I would write a for loop that that goes through the numbers 1 through 100. And then I would probably write a list. If I really want to print out, if I want to show the list that make sure that each word either says fizz, buzz, or both, or FIZZBUZZ, then I just write a list saying, all right, here's number 1. It calculates a number, and then it prints out a number saying 1 is, and then it'll say FIZZBUZZ or FIZZBUZZ at the end of it. And then that's the way I do it. Okay, so I thought it was like a program that if it takes in a number, it'll spit something up. But no, you're talking like you just want to automatically run through it. Okay, got it.
Right. So for the most part, that's like, again, borrowing syntax, that is what everyone's first, like, oh, this is just how I'm going to do it. All right. And depending on how big the number you get originally is, between like 1 in 100, 1 in a million, or whatever, you start to need to approach it slightly different. All right?
Okay.
So 100 is a low enough number for the most part that if you search through all 100 by going through that like loop like you did, right? That's called a linear search. You literally search through everything in a line.
You talked to me about it. Yeah.
So that's 100 searches, and that's not that big a number.
It's not efficient. It's not very efficient.
It's not efficient. That's the key, right?
Yeah.
And technically, if there's a really big number, and the FIZZBUZZ problem gets even harder because, like, for example, you can binary search for one number, right? And that's what you could do if you had one individual input. Look for that number, right?
Okay.
But since there are multiple of them, you need to start weighing in, like, is it faster to binary search this many times? Is it faster to actually linear search it that many times? And then there's different ways that you can define how your code runs.
Well, if you know it's divisible by 5 or 3, excuse me. So I'll put this in. I guess what you could do instead of going through each and every number, you can just multiply. How would you do it? Because you basically only need to really look for the multiples of 5 and 3, and then check whether either of them are, if either one is both also divisible by 5 or 3, right?
Now here's the other issue, though, right? I gave you a bound of 100.
Yeah.
Right? That's a relatively small, relatively nice number. Theoretically, this number could go up to millions and basically infinite. So you don't know specifically how many you're looking for, so that complicates the problem even more. That's why there's so many variations to FIZZBUZZ, and why it makes a good technical coding problem. Like, it starts very simple. I'll just write for loop, check it. We're good.
Yeah.
But then if you start talking about the more complicated ideas of running code around it, right, you can actually get a sense for how people approach problems, think about things, and like determine their algorithmic approaches and stuff, right?
Okay.
And so that's the one thing that I like to do to, like, again, just to have a conversation with someone. If they say, oh, I'm like a really good programmer, it's like, all right, we'll try this.
Okay.
And depending on how we talk through things and figure it out, you can get a sense for that. And I mean, again, anyone can sit there and learn the basics and just kind of like brute force their way through, which linear search effectively is a brute force method where you check literally everything. But if you know how to bound your problem and kind of like figure it out in a more efficient way, how to like write modular code, because there's another thing that I can add on for like, now you need to solve a specific subset of this problem. How do you break down the problem into subsets of problems, so on and so forth? That, I mean, if you can't do that, then I don't think you're that good a programmer personally.
Yeah, and I'm really fixating out on the problem now because I now see the extra parts you could do about it, like the way to go past a linear search and do, I guess, what you call binary search.
Well, binary search is just one example, and to be honest, binary search may not necessarily even be the best approach, depending, because binary search is super, super good when you only need to find one value.
Mm-hmm.
All right. If you only need to find one value, what binary search does is it we're not talking like super tech. There's probably people who might be listening to what the heck is binary search. But functionally, the way it works is, intuitively at least, is that if a number is like bigger than the number you already looked at, but the number that you know you want is smaller, cut out all the numbers that are bigger. You don't need to look at them anymore. Right? You know that a number that is what you checked is smaller than the number is bigger than it, and the number you're looking for is smaller than them both. So why do I need to look at that? Right. So you basically only need to look at certain numbers because you gain more information by like basically each step you're looking at things.
Okay. Well, to give you an idea of what I would do to fix that code of like, to make it more malleable to handle ranges bigger than 100 or a million to make it go faster rather than going through every single number. If I'm just looking for the numbers that are only divisible by 3 and 5 and I don't care about the other numbers in between, then I would just, if I know it's 3 and 5, I would create a initial variable that is just 3 to the, 3 to the power of like 1. And then add that, or 3 to the power of n, and I would just add up n each and every time, and then do the same thing with 5 as well. Because then technically, with that, oh wait, no, it wouldn't work. No, because it has to be, no, I have to times it by.
You don't have an upper bound.
Sorry, I have to do, well, what I would do is if I don't have a number bound. With this problem, if I don't have a number bound, then the problem just goes to sort of infinity because there's no real. Because if you want to be finding every single number in the numerical spectrum, right? Then there's infinity is a literal thing. It's just when we say it's so large that it's not it's going to come to a certain conclusion.
Oh, okay. Oh boy. So now this is like again the intersection between computer science and engineering because again, we can't have an infinite number. That's not going to happen, right? It can be theoretically very, very large, but then it's not infinite. But if you approach it from like a more theoretical computer science kind of like point of view, you just kind of treat it as, yes, there's an infinite number. So anything that you need to like terminate or have a finite value to calculate doesn't exist. And so it depends on, obviously, if you're actually like building something, because there's no infinite, at some point it's bound to bully through that stuff.
Well, yeah, like I mean that happens in code all the time, right? It's called like the stack overflow issue or something like that. I've heard of that a little bit in Pokemon games.
Not
apparently, okay, well, it's kind of like this idea that the number is so large that the program, like you're right, like that we can't. That's what while loops are for, right? While loops have that error where if they just run infinitely, they're just going to not.
But they still have to have a termination condition, right? Because the while loops will, your program won't end, and so
exactly, right? So like the question will be like, how many numbers do you want me to find that are divisible by 3 and 5, right? And then that's going to create, because if you just say, oh yeah, find me all the numbers in the entire spectrum of the numerical system that are divisible by 3 and 5, I'm like, well, good luck. I'm just going to say, yeah, it's infinity. There you go. Like, but if you have to give me like, oh, I want you to find 5 numbers, the first 5 numbers in numerical spectrum, or I want you to find the last 5 numbers before right before I reach 1 million.
So now this is like that next step, right?
Yeah.
So we're approaching this as we have one like solution that we run through, and that's it. But what you could do, and what you probably should do instead, is break this down into multiple sub-problems, where now we can check for like a specific subset, or we can check for like a specific like first number, and then you can have other things around it that will catch errors, or if you have it like if it's way too big, if it's way too small, like there's things that you can do to kind of like make a composite problem and break down this like theoretically uncomputable problem into something that is realizable is the software engineering part of it.
Oh, yeah. And that's where it comes like, you got to ask the person who's asking you to design this code, like, what do they want out of this, right? Because they'll give you like a blanket problem and you'll be like, well, okay, I need to know some more information. So let's talk about it a bit.
Yeah, that's why in the interview, like I started with, you can ask me questions.
Okay.
Right, to kind of figure it out.
Yeah. And so in that interview, what brought about this whole question about the coding and the FIZZBUZZ interview question, if you want to talk about that part?
Again, it's the idea that a bunch of people, I hate to throw shade like this, but like, again, people pretty easily get jealous of like, oh, that guy just writes code. Writing code isn't that hard.
No.
Or people are like, I'm a really good programmer. It's like, but are you? And I'm not that great myself either, but like, there's just things that you aren't aware of or you don't pay enough attention to if you're not like really immersed in software, right? There's a lot of people who tangentially kind of pick it up through like a random course because they're in STEM, and that's just like, everyone has to take like either a scientific computing course or something, and that's what they assume is programming because that's all they have. But scientific computing is meant to basically be a multi-purpose calculator for you, let's be real.
Okay.
It's not meant to actually like solve a problem so much as help you out in like data analysis for like running stats and stuff.
Okay. I think it's more, I think good programmers come from people who don't just know how to write code. Because like there's some people who really just like to sit behind a computer and write code all day, every day, and just like to be told very specific conditions about how to do things, right? But then they don't know how to ask the right questions, I guess. Like they're probably, I guess here's the thing, they're probably really good with technical information, with about like, oh, I know how to write in this language or that language. I know how if you give me like a certain problem in front, like, if you give me like very hard specific limits within the code of how to do it, I can probably do it, right? It's kind of like that whole first year programming course where sometimes very early on, some people would like it because it's just like, oh, here's the very technical information about how to write it, or about what problem you solve. But then all of a sudden you're given like a more soft problem, I would call it. Like basically the problem is not given right in front of you. It's like, oh, here's what they're trying to do. You have to write a code that helps them with that, but you don't know but you have to create your own limits. You have to create your own variables, right?
Right. So if you're the senior software engineer on a job, you're the one that has to have like the big grand vision and how everything gets laid out. And that's again the idea that you can break down not theoretically, but like a supposedly impossible computing task into smaller like subsets of tasks. It's called modular programming, right?
Yeah.
So you break it down, and so now you need to solve this smaller problem, and to solve that smaller problem, there's like more smaller problems.
Yeah.
And so the juniors are usually the ones that are like, yeah, you know, you're given very specific things of like, do this, do that, and so now you just write the code. But then the ones that have to like organize everything, put it all together, and like break down the problem are usually the more senior ones. And now that there's so many working subsystems and stuff, it starts to get to the point where people actually do need to really like speed certain parts up to meet again different contexts of different programming, because programming is a very broad term.
So what makes a bad programmer then? Like we keep talking about like, you know, sometimes a good programmer will be someone who has both the technical information and also the communication and the soft skills to communicate a generic real world problem and turn it into a mathematical problem.
I don't consider that a soft skill, actually.
All right, what do you consider that then?
I consider that also a technical skill of how you can break down a bigger problem to smaller problems. That's not a soft skill in my opinion.
Well, I was thinking more like communication wise. Like I guess in terms of breaking it down, yeah, I guess you're right. It could be technical. I'm more thinking about communicating certain ways to client. Like for example, a client or the customer in this case will, you know, give a general piece of information about like what they want to do, and you can't ask them too much technical information because maybe they don't know it, right? Maybe they don't know exactly like when you talk about dummy variables, limits in your programming, loops and things like that, where you have to say like, well, where's my end conditions? Like you have to grab that from them. Or you have to write the code with this assumption, and then when you go and tell them saying, hey, here's your code that you're going to work on, here's a limitation of it. Are you okay with this or not? And they'll say yes or no. And I think that's a bit of a communication skill because I think some people are too technical focused. Maybe that's my understanding, where they just want every single piece of information given to them so that way they can just put it into their code and that's it. Whereas a good programmer in some case will take as much information as they can, see what parts are required that need to be asked need to get information from the client or the customer, and what can be assumed right now until the final product's done.
So like the thing is, I still consider that like a technical problem or like a technical skill, right? In the sense that like I don't know. I guess my bounds for what makes like a technical like problem is a little bit different, because I still think that like even if like you're trying to like I guess pull words out of like a clients aren't necessary. I mean, clients aren't necessarily right. I hate to say it like that. But, I mean, because like what happens more often is you get feedback or you get like crash reports or whatever, and you and again the more senior people kind of sift through it and kind of like, you know, work through it that way. And that's again the idea of the ostrich algorithm, because this is another thing that people tend not to think about very much when it comes to programming. Because again, my original like thought was, I agree that people need to know more about tech, but not necessarily about programming, more so just how computers run and how computation devices run in general.
Okay.
Right. And that's what more people should be aware of, because even people who have taken their like original programming courses, and to be fair, I've never taken this course directly either, but I've paid enough attention so that because it's very applicable. So everyone hears about operating systems and stuff, you know, like Windows versus Apples and all that stuff. So one thing they don't consider when it comes to programming is that when you write an OS is a piece of software, right? It is a computer program. Now, the interesting thing about that is that it's very different than what most people's introductory programming courses are like.
Okay.
Because you get taught very consistently, oh, your program has to end, right? At some point it has to end.
Yeah,
or else you stack overflows, all that junk, right?
Okay.
And at the same time, all right, when you're very introductory, you want something that just runs period, end of story, not necessarily what is running in time, especially experimentally. Now, the thing about an OS is that it has to effectively update in real time.
Okay.
And so if your code isn't fast enough at certain points, because again, that's how you break down a big problem to smaller ones. If a smaller problem, because your monkey wrote it and your monkey's not so good,
Yeah.
now it's just taking forever to run, then your OS lags and everything else gets bottlenecked by that. And on the other hand, you want to write a program that will constantly be taking inputs and basically working in real time, because your OS shouldn't just suddenly stop, right?
Yeah. You don't. Your computer shouldn't just suddenly stop working for whatever reason. Yeah.
Right?
Okay.
And so again, these are things that people don't consider, and they don't think about that in the sense of like, oh, this is how you program. But because there are more rigid conditions now on how you program an OS and how it works, there's more things that you need to be aware of for like how to put things, again, runtime, and like how to manage a program that will constantly be like running.
Yep.
Because this is where the infamous like ostrich algorithm comes in. So the thing about an OS is that because it is constantly taking inputs, giving outputs, running in real time, and all these, basically passing a lot of data around, right? It is possible that it comes across some like extreme edge case of, wow, this number like that passed around a bajillion times started causing a bug.
Yeah.
Right? And so the ostrich algorithm is basically, as the name would imply, act like an ostrich, stick your head in the sand, ignore that bug.
Oh, okay.
The idea is that by trying to handle that extremely rare edge case, you will probably introduce more bugs than actually fixing it. And so what you do is you just basically restart everything from scratch, so reboot your system so that you don't have this big data like backlog basically of how the program was running for forever, and hope it doesn't happen again.
So it's not just a magic. So when your IT guy comes over, or girl, and comes over and says, yeah, let me just turn your computer off and on again, and it solves everything. That's quite literally just a technical bug fix where they're just trying to remove that big number that might have been on. And you know what? That's what I talked to my girlfriend about. I complain about her all the time, how she doesn't turn off her laptop. I'm like, no, you're going to get annoyed by it because something's going to run lag. Something's going to happen where it's just going to slow down. You just need to get rebooted.
So here, okay, let me explain that from like the computer engineering point of view, people who don't know, all right? And this is my like knowledge egg for today. So the idea of turning stuff off and back on is actually very important. Because what happens is you can break it down even lower depending on how you want to go, but there are like functional units called flip-flops, believe it or not.
Yeah, I think I've heard about them a bit, yeah.
Right, and basically they are state machines. They store numbers, and then depending on how those numbers kind of like go about their business, that's how you run through your programs and stuff, right? And so what happens when you power cycle flip-flops is they get turned on at a random state. And so dealing with that random state is usually fixed into like the system, so that it will automatically start at a point that makes sense. Right? No matter what it randomizes into when you first turn it back on, from that random initialization, it will move into something that is stable and works, assuming that your program actually isn't like stupid and your computer isn't just a pile of junk. If it actually was built the way it should, right, having it re-randomized to resettle to something that is stable will usually, be basically an ostrich algorithm. I'm gonna ignore that. It'll work.
Got it.
So there's actually like something built into your systems for why you turn it off and back on.
Okay. So I think if more people understood that, maybe that will create a lot of less complaints. I always think the problem is that because everyone pretty much owns some form of computer, whether it's a phone or it's a laptop or a desktop, whatever case may be, because it's so widely spread, everyone just thinks that it's so easy to do because it's so commercially available. But they don't realize like how much effort it takes to do that, right? It's why like it's the same with car mechanics, right? Everyone, like, a lot of people have cars, but they always get broken. Something always goes wrong, and they always need someone to fix. That's why there's so many car mechanics around doing the work, right? That's why you have so many people doing IT work, because some people need their laptops fixed all the time. And yeah,
it's really funny that you bring up the car thing, because that's like the exact analogy that one of my good colleagues and supervisors kind of like uses to explain artificial intelligence to people sometimes.
Really?
Yeah, because the idea is that, everyone, for the most part, everyone has a car, or everyone has interacted with a car in some way. And if you tell someone, hey, drive this car, it's relatively easy to learn and you figure it out, you drive your car.
Okay.
But if I tell you, hey, this is how your internal combustion engine works, during your like driver's test or whatever. You're just like, why do I care about that? I don't need to know the specifics of how my like car works to drive it. And so depending on how you want to look at it, it's like how much do you actually need to know? And so that's the analogy he gives all the time.
Okay, that's true. Yeah, because it really depends on how self-sufficient you want to be, right? If you want to be the type of person like myself who likes to change their own tires, want to change their own oil at some point, just don't have the really tools to do it, and some other car work, then I want to know that sort of stuff, right? But I know people who just say, I don't know about that, I'm not good with cars, I'm not good with computers, I'm just going to hand it off to Bob down the street who does all that, and I'm just going to pay him $50 and he's going to do it for me.
Yeah, so like again, that's why I think
that's the capitalist mindset.
No, that's why I think people who say, oh, everyone should learn how to program, that's a bit of a misnomer. I don't necessarily, because it's like the original thought was people kind of like sell programming as talking to a computer and knowing how, and giving it commands, right? Mm-hmm. That's not necessarily the equivalent that people need to know in order to be able to have a better understanding of things. Like my little OS explanation, for example, all right? If you're stuck on the same loading screen for a while, right, and after that explanation I gave you, right, you could probably intuitively kind of think, oh, there's one subroutine somewhere that's just running really slow.
Yeah.
So now you have a little bit more insight of how your thing is working. But that's not necessarily like programming so much as just how computers compute.
Yeah, I think that anyone who says it, it's the same thing that everyone says. Like everyone needs to learn how to cook. Everyone needs to learn how to drive. Everyone needs to learn how to manage their car. Everyone needs to learn, excuse me. There's so many different things that everyone says, like, you should know this, that are, quote unquote life skills, right? And it depends on how much the people actually want to care about it, right? Like I care more about my car and maybe a little bit about my laptops and such. And, but when it comes to cooking, for example, I don't care that much. As much as like people say, well, you should know how to cook. It's like, yeah, no, sure. But like, I don't want to get fancy food. I just like to have my coated chicken, steamed broccoli, and maybe some steamed corn as well, right? And mashed potatoes. And mashed potatoes, when I say that, I mean just potatoes, salt, pepper. I don't know why I said sugar. Salt, pepper, and like maybe some butter, right? And that's it. And some people are like, "Wow, it's so bland." I'm like, "I don't care. That's what I like." And it's the least time efficient for me. And the main thing, I'm going to go on a little side tangent. Like my girlfriend is very big on cooking, all right? And it's because she comes from a background and family that it's not just about the quantity of food you make, it's the quality of it. Like it's very, very specific because she will sometimes go to places and eat, quote unquote white people food and say, oh, this is really bland. I'm like, no, I think this is fine. And so, but she just doesn't like it whatsoever, so she won't even eat it. I'm like, why? It's still food. It's still decent food. But for her, it's just all about the quality, and that's why she spends so much time on cooking and everything like that. So I think it's the same, maybe something similar to people learn how to code. It's like, I don't need to know the very, very in-depth specifics about how my computer is running. I just need to know, maybe I don't care about it. Maybe I just want this program to work and I'll just pay someone to fix it, or I'll just ask someone about it who knows more than me to do it anyway, because I am not bothered and I do not give enough time of day to figure it out myself because I'm just focused on so many other different things that I don't want to focus on this.
Yeah, that's capitalism in a nutshell. The thing is, I don't necessarily mean it from a point of view of, I'm going to start problem solving all my stuff. Right? Mm-hmm. It's a little bit of just having more empathy, I guess. So, oh my God, I can't believe I'm making this relation. So the other day when I was commuting, there was someone who got hit by a train.
Ooh.
And they passed away.
Oh no.
And so because of that, there was obviously a bunch of canceled trains and stuff as they were, figuring out the situation.
Yep.
And I was like, okay, cool. It happens. Unfortunate. And so whatever. The train, I'll catch a train eventually, right? It's fine. Don't worry about it. But then what happened was there was this, bless his soul, there was this slightly older gentleman who was just working at the train station trying to say, hey, this train got canceled, whatever. There was an accident, thanks for understanding, we'll let you know what happens, but the trains are canceled for now.
Yeah.
And man, everyone was so mad.
Really?
Someone died. And you're mad about them canceling trains? Chill.
Well, it's because the daily life is interrupted, right? It's the same thing with car crashes and traffics. Like you see the accident happen, you're cursing and swearing up until you see the accident, and then you're like, Oh, okay. I'm gonna shut up now.
No, and that's the mentality that I think people jump to very quickly when they have less understanding of what's going on.
Yeah.
Right. So again, I know what.
Well, actually, before you go on to so when they were first announcing it, did they say it was just delayed because of a problem, or did they say specifically that someone jumped in front of a train?
So I don't know this business will jump in front of a train.
Sorry. Did they say that someone was in front of a train?
All it said was there was an earlier fatality, and it was like where all the train schedule and stuff. There was an earlier fatality. Trains are canceled.
Oh, so then everyone should know about that. It's like, yeah, you can piss and moan about it, but that's the way it is. It's like, then someone will be like, well, why the hell did someone go in front of a train? It's like, well, who knows why?
Things happen.
Yeah, exactly. Like, it's not like, people jump fences all the time. People get around there. It's entirely possible.
It's cold. People might have just slipped, and that's really unfortunate. But,
exactly, right.
I mean, anything could have happened. And you yelling at this, like, really old guy who's just doing his job isn't going to help.
Yeah, it's like you're yelling at the messenger, not like, and what's the messenger? The messenger's not going to do anything. The messenger's going to stand there and say, well, guess what? That's the way it is. Wait, and they're going to say, well, I'm going to talk to you. Like, if someone says to the guy, I'm going to talk to your boss, it's like, what the hell are you on? That makes you think that's going to solve anything.
Yeah, anyways, so that's kind of what I mean by, like, because how there's, like, road rage? I think there's, like, tech rage. When someone has, like, really mad at their phone for whatever reason. Like, I mean, if you have some more understanding of how this works, and it's not this, like, a magical device that solves everything, that you can have a bit more of an appreciation. And I guess this kind of continues the tangent that I mentioned, like, in the previous episode, too, of, like, why there's an app for everything and why people just, like, assume that absolutely perfect or whatever. It's like, I mean, it's still just a piece of, like... It's a product.
It's made by someone just like you that makes mistakes, that doesn't think of all the situations, and that doesn't.
It's literally not possible. Actually.
Yeah, exactly, right. So like, but people are just so pissed off because it's like, I pay for this, I use my hard-earned money for this, yada, and then and like, I should get the best product ever. It's like, no, like, guys, it's a product, and not everything. Certain things fail, certain things don't work out very well. That's why there's like different types of phone systems, because not one phone can do everything that you want it to do. You have to find the right phone that's right for you. It may not do everything that you want it to do, but as long as it does most of the things you want to do, then you should be pretty happy about it.
Yeah.
And like, it's the more people don't understand. I don't think it's about that. I think people understand. Like, I've gotten mad about things I understand. I still get pissed off about it. It's a problem of how much of an inconvenience it gets into their daily lives. I think that's the problem. Is like, think about like this with the trains, right? That person or the people who are pissed off are not pissed off that the trains are canceled. They're pissed off that they now can't make it to whatever event, work party.
It was a sports game.
Sports game that was happening at the time that they can no longer make it to, that they already paid for, that they're looking forward to, and now because of this accident, they can't do it anymore. I'll give you another example. So I got really pissed off when I got, I don't know what I want to call it, unspecified virus. I don't know how much YouTube handles it or not. I got the Corona Ultralight. So I got that, and I was supposed to go to a party that week. It was like the very first time I ever got it. Right? It was after I got the shots and everything, and I was just super pissed off because I couldn't go to this big event that I wanted to go to the entire time. All right? Super unfortunate incident. I couldn't do anything else about it. I had to stay home and just lay off about it. Right? It's not like I'm not pissed off about the virus more specifically. I'm pissed off that I just can't go to the event that I was looking forward to the entire time. Right? That's what people get more pissed off about. Is I'm not pissed off about the OS being a problem. Here's the thing: if my computer wasn't running at all, or if my computer wasn't running but I'd never really used it, then I wouldn't care. It's if I'm using it every single day, or I'm using it the night before an exam for some work-related purposes, that all of a sudden it stops working. I'm like, well, now I can't do anything. Now my entire plan for day or weeks ahead of time just gets canceled because of this one problem. So I don't think I don't think giving them understanding of the problem is going to fix it. Because I understood why I couldn't go to the party because I had COVID. I understood why I couldn't do any of that. But I was still pissed off about it no matter what. So I think that I don't think any level of understanding, people understand how cars work. People understand that when you don't
have gas, it doesn't turn on.
Exactly. Or when when your car all of a sudden shuts off and you get an understanding that because you didn't go for a maintenance check in 2-3 years. It's like they're not pissed off about that. They're pissed off because it's now interrupting their daily life. And I don't think giving them any better level of understanding. Some people may understand and be like, well, that's it. But other people will still be just as mad, just as pissed off, even though they fully understand the situation. They just have no other way to express their frustration other than just being mad at the one thing that's causing this issue.
Yeah, I guess maybe. Yeah, I mean, because I'm also thinking about it a little bit like on the lines of like requests, I guess, and that's why I brought up there's an app for everything, right? If someone says, "Hey, can you do this for me? I got this like multi-million-dollar idea." So okay, I'm going to take another hard tangent because this is something else that like oh my god, this is partially the reason why I can't watch movies anymore either. When you know a little too much, it's just like this doesn't make any sense anymore.
Okay.
And maybe it's like, I'm on a hit list now somewhere, like, I'm a conspiracy theorist or anti-conspiracy theorist, whatever. Anyways.
Yes, continue.
So, if there was no mic attached to your phone, okay? There is no mic attached to your computer. Mm-hmm. There is no mic attached to anything on the wall. There is no mic in like a 5-mile radius. Okay. And in fact, we'll take another step further.
Yeah.
There's no electricity in like a 5-mile radius.
But dude, we're in Canada. You got to say kilometers. You got to go metric.
True. Okay. So 5 miles is longer than 5 kilometers, though. Anyways.
Yes.
So you're just like out there, stranded, right? And now your immediate concern, for whatever reason, is now someone might be spying on me. Okay. It is physically impossible, no matter how good technology or software or anything is, if there is literally no electricity in like a 5-mile radius from you, right? There's nothing technical that can be.
Does that include in the air?
Yes.
How? Okay, yeah, continue. Yeah, continue your thought, and then I'll comment.
So, it's the idea that like and it's kind of spread from that idea that like somehow we're gonna write some AI software that's gonna take over the world, all right? Mm-hmm. So, if I have no way of transmitting data, all right, even if I did do that, all right, so I have this laptop in front of me, there's no way to transmit data on it, whatever, right? Say this, I like yank the Wi-Fi card out entirely, it's just its thing now.
Sure,
right?
Okay.
And I write this like super sentient piece of software on it. It's not going to do anything. Even if it knows how to like quote unquote take over the world, if there's no way for it to do anything, right? Because that's not how physics works, then it's not going to do anything. You're fine. Don't worry about it.
Okay.
I don't even know where I'm going with the rant anymore.
Well, I thought you were getting on the point of how, like, why do people feel so afraid if there's literally no technology around you that can spy on you? Like, for example, you guys said the mic/electricity thing. Yeah. I was going to counter that saying, well, cameras and super close-in lens exist that you can actually still look at them, but it depends on what you mean by like, a 5-mile radius of like no electricity. Is it like nothing with nothing that has like electrical pulse?
Yeah. When I say nothing, it is physically impossible for a computer program to somehow just kind of jump at you and do magic. Right?
Yeah,
It's not going to happen.
Yeah.
Right? It's just, I turned the power off. Like, it's just not going to happen.
Dude, people have gotten way too scared because of Terminator, because of space, was it Odyssey 3000? It was one with the HAL.
Dude, I stopped watching these movies because, it's just not how this works, right? Like, it's just not going to happen.
Movies are like, they have that fictional element to it, right? Like, that's the idea is that you're...
That's why it's sci-fi, right?
Yeah, exactly. You call it sci-fi. Like, like, how should I put it? Like, Star Trek, right? They had androids, right? But then the androids were still... Even in this Star Trek futuristic ideology with, like, data... Yeah, have you ever watched Star Trek?
No,
Next Generation?
I don't know.
Okay, do you know who Data is at least?
Nope.
Okay, so Data is Brett something. I can't remember the actor's name, but he played Data in Star Trek: Next Generation, and he was basically an android, right? So the android, he very much acted like an android, so to speak, but he tried to learn. He learned a little bit of human emotions here and there, but he was never really the leader. Like, even once in a while, he said, like, how do I lead or something like that. It was just basically following a protocol, and that's it. And everyone was telling him, like, no, that's not just about being a leader, right? Even Picard was saying that same thing. So it's not like AI is going to just inherently take over everything, like in Terminator or anything like that.
Yeah, so what I'm getting at is there's no magic. Yeah. And so if you have an idea of how this stuff works, then you can... gets me more sensible about like technology and how things work.
But
I mean,
people,
there's, like, Black Mirror and all that stuff stirring things too.
No, Black Mirror is crap. Okay, I've watched Black Mirror. It gets really boring after a while. Same thing with same thing with Love, Death, and Robots. Have you heard about that show?
No.
It's a Netflix one. It's like an animated one. It actually has a couple of main actors in it, but it's the same thing. It's like, all about love, so like, sex and a lot of times, death, so a lot of gore and fight scenes and all, and then robots, so it's like a lot of futuristic stuff, right? So I was going to mention, I think you're going along the same path of like how people felt when self-checkouts first started popping up.
That's a strange tangent.
No, it is. No, like let's think about it like that, right? Like you're saying that you get really upset when people think that AI is going to take over because of these stupid ass movies. But people got a real feel. I think some people got a real fear about it, and I see it every once in a while whenever I look on Facebook and such about self-checkouts where they're replacing cashiers, right? Most of the time. I would say, my personal preference is that if I'm buying like 3 items, I'll go to self-checkout. If I'm buying more than 10, I'll go to a real person because it's a lot easier to manage that way. So we were saying, I remember seeing a post from several different people on Facebook talking about how like, since you're replacing cashiers now, but you still have someone at the end checking the receipt on your way out, then I'm just going to walk out anyway because you don't care about it since you're doing self-checkout. Just hire back the cashiers. I'm like, well, it's not like, and the people will, if you want to be really conspiracy theorists, like this is like the first step for AI takeover, right? For taking over people's jobs and such. I'm like even some people who I talk to are like, yeah, they're going to start taking over major workplaces. I'm like, you guys are dumb. Like the reason why the self-checkouts work and why half of them are also always off, if you're going to go like McDonald's or anything like that, is because they have one specific function to do and the options are still being inputted by yourself. It's not like it's running itself. It's not like you're walking up to it and it's immediately taking your thought pattern of how to do it. Like, no, it's just taking a very manually automated process that is usually done by a person and now putting it onto a computer, which is how a lot of things were. Even looking back to the 80s and 70s, systems that people used to do by themselves or used to have people to do all the time now are just run automatically through programs or through, AI robots, whatever you want to call it, right? So I think people have a fear of that because they watch Terminator and movies similar to that. And Space Odyssey, I think it was what it was called. Because, the HAL 3000, where he's like pulling out the cards in the simulator room because the robot's trying to kill him. And then they go outside and they see cashiers' jobs are being taken over. They see a lot of manufacturing jobs that used to be people being brought to different countries. So people are losing their jobs that way. And then you're getting people like Elon saying like, yeah, I'm going to create a neural link that let people talk to each other, and all that compiles on one another. And then if you put people in the right conditions where they're in that area where their jobs are not being threatened by the AI and such, by things being replaced by computer programs. Hell, remember in Charlie and the Chocolate Factory movie?
Oh
did you watch that with Johnny Depp? Remember how the guy lost his job due to the machine?
Yeah.
That's what I mean. Things like that pop up all the time.
Here's a funny thing that you mentioned that exactly right now. Literally a week ago, there was this news article about how, you have no idea what I'm going to talk about, ChatGPT. So, and you mentioned Elon Musk, right? So Elon Musk is one of the people behind OpenAI.
Okay.
And OpenAI is, as its name applies, open source AI projects help people to develop this stuff, right? So they put out ChatGPT, which is basically it's a bot that you can actually have a conversation with.
Okay.
And believe it or not, it is, it's good enough, right?
Okay.
Or if you punch in some stuff, you get some funny answers. It upholds a decent conversation. Right?
Yeah.
And so they're combining that with the different ways for programs that learn to write code.
Okay.
And they call it alpha code. And a week or so ago, they put out this article about how it actually puts out functioning software.
Really?
In the sense that the code will run.
Really? Okay.
It doesn't necessarily mean that it's good. It doesn't necessarily mean it's a problem.
It's what you got back to about with the whole efficiency thing, right? You can write an OS, but if it's laggy as hell, no one's gonna want it.
Right? So the code works, air quotes, right?
Yeah, okay.
And so it's wow, they're off my job. I'm not that worried right now. You stay ahead a little bit and you get into that idea that it can actually be a fun, half functioning side tool, right?
Yeah.
So it's the same fear that happened in, I think it was 2014, 2013, almost a decade ago now. There was some AI developer, some clinician or something that said that radiology will be obsolete, or at least the field of radiology won't need people anymore by the time it's 2018 or 2019 or something. And believe it or not, there's still radiologists working to this day.
Exactly, right?
So,
Like all these like buzz articles are like just trying to stir the pot a bit. And I think people are really overestimating what technology is. Just like, I mean, it is amazing. Like, we think about like to the 80s and 90s and then what we have right now, right? Like, only 20 years ago, we talked about it during one episode, right? Like, 20 years ago, we didn't have cell phones, right? We didn't really have that. It was still a new technology. And then if you look on like the music videos and like media propaganda that had it, the funniest thing was I saw like a music video where a person was texting into like an Excel sheet. It was this weirdest thing on a music video. It's like from some major music video. I can't remember where.
So here's the funny thing though. Actually, I want to bring this up because you're kind of mentioning it.
Okay.
Someone can fact check me. I don't know this for sure, but when I first sat in my very first programming class, and I shouldn't really call it programming, it was more like the computing class, right? So it's like teaching you how computers work. So the lecturer said that pull out your phone, you set it on the table, it's okay. So this thing in front of you, right, is so powerful, and you still complain about it. Now here's the thing that you don't realize, that we went to the moon, like we literally did all our calculations and everything, and went to the moon with the computation power of the Casio calculator that you were forced to buy to write your exam.
Exactly. Yeah. Exactly. Right.
Like put those two next to each other, and believe it or not, there's actually a very major difference.
Yeah. No. Exactly. Right. I think I actually have a different tangent on, but I'm going to talk about it when we talk about movies or music and such. Is like it's the power of convenience and then the loss of inherent technical knowledge because of that convenience. It's the same idea where how we take a drafting course in first year, right? We take a drafting course and we are told, and we have to draw it on paper. And I don't know how many people, I didn't really complain too much, but I know some people probably really complain. That's like, why do I have to do it on paper? I'm always going to do it on a computer anyway, right? It's not about that you're going to do it on a computer later on anyway. It's about the fact that you got to learn about it now. So that way you understand the fundamentals. So that way when you do it via something easier, you know what's going on behind the background. I actually had this recent idea about, I was doing some pump calculations for my work. And I got really mad at myself because I'm like, man, why don't I have like a specific Excel sheet that does this? And then for like my entire day, I wrote a whole Excel sheet to be able to calculate pump calculations just by inputting a few numbers. But I had to learn all that fundamentals first because I can't just go online and look it up and then put in a few numbers and then because each site says a disclaimer says that. Yeah, exactly. Pray or like just assume that like it's entirely right or that it's assuming exactly what I think it is. Because sometimes I go online and I see some of that stuff. I'm like, wait, that's not exactly what I need, and I need to be very specific about this, right? So I had to write it all myself, and then what I'm thinking is like, man, if I give this to someone else, I'm hoping they have the fundamentals to understand how the sheet works, because that's the biggest problem whenever I had to write a tool, create a tool for something.
It's similar to like documenting code, right? And that's another thing that I personally think is really important, and I take a lot of time to document my code very properly, but a lot of people that I talk to don't.
Mm-hmm. I know it's one of those things where like you don't think of it in the moment when you're writing because you're like, oh, I'm using it, I know how it works, but you forget that you're not one person that's going to be using it. You're probably going to be 10 or 15 different people that are going to use it throughout the lifespan of either the company or of the way the tool is going to be used, right? So that's what I was thinking about. Like I got to create the tool and create notes and create like documentation instructions. So that way later on, if I forget how to use it, someone else knows how to use it. Or if someone else looks at it and isn't quite as understanding or even forgets some of the core concept of how the tool runs, that if they want to look into it, they can see the notes, understand it, and then move on from there. And I think that's what some of that loss happens, which what you're talking about there with what your lecturer was saying, right? Is that we have all these nice conveniences now, and some of the fundamentals get lost. Now, I'm not going to say I'm not any different, right? Like, I think I never look at, like, can I do what scouts usually do, which is look at a physical map and actually read my directions and such like that? Maybe not. I always put everything into Google Maps, right? There's certain things like that, skills that should be taught and should be relearned, but I think it's just weird. I don't know what I call it, like this weird mentality that because I now have it as a convenience, I don't see any other reason why I shouldn't use it. Like, we lived through the time where if you had a phone out in class, you would get penalized. Or if you had a laptop out, it would be like, why are you bringing a laptop out, right? And if someone did have a laptop out, it's because it was a very specific condition. Like maybe they had like a hand or a foot muscle condition that they couldn't always like write every single time. They had to do typing, right? Things like that. And now nowadays, I don't know if high schools are the same way or not, but I imagine laptops, tablets, things like that are so much more.
To be honest, I don't know. In fact, I was gonna like ask you if you think people still learn how to do like long division and stuff in class.
I don't think so. I don't think I can't remember doing long division either. I think at a certain, because we learned it at a certain point by hand, but then after all they say, oh, just use a calculator, and then you just use a calculator from now on, right? So they just always tell you to bring a calculator
Like
all the
if
time.
you're 8 right now, do you still learn how to do long division?
That's the thing. I don't know. I don't know, man.
Oh my god! I guess that's something that like if you're listening and you're 8, I guess,
Yeah.
and you somehow follow through this coding problem, coding like I guess talk, and you can leave it in the comments because I think that's all we have for today.
Exactly. No, my girlfriend just is just out right now while we're having this podcast, so she's just texting me some stuff about buying things. So maybe she'll come on the podcast one time. I don't know. But yeah, if that's all the time we have for today, then we'll call it there. I'm Zach.
Okay.
And make sure to like, comment, subscribe, and we'll see you again in the next one.